Hi, let's have a look at this. This is we kept what we learned last week. This is a SC flip flop. Okay, this is a negative trigger. You can see from here. It's got a bubble here, S and C, right? This is a truth table. When S1, C0, output will be a 1. When S0, C1 will be a 0. So you can see that is sort of like active high. S and C0, 0, the output will have no changes. So this is 1 and 1 is invalid, right? That means you cannot tell the output change to a 1 and 0 at the same time, right? Just check it out. Initially Q is equal to 0. Okay, we are only interested at the negative trigger. This pawn, this pawn, this pawn. Alright, something will happen. Okay, 0, okay, we maintain 0 until this pawn. So what happened? Check it out. S1, C0, so your Q will be set to a 1 immediately. It will remain a 1 until the next trigger pawn at this pawn. Check it out. S0, S1, C0. So the output maintain a 1. Still a 1, right? So it will maintain a 1 on the next trigger pawn. This is a 1. Now C equal to 1, S equal to 0. So the output will drop to 0 and so on. What about this? Another example, right? Now this is a clock signal, right? Negative trigger, but this time the S is at the same line as this trigger pawn. So what happened? I'll tell you. When this happened, you consider S, okay, is a 0 before, right? It's on the line 0 or 1. How do you consider this? On the line of this trigger pawn, you consider S is equal to 0. So 0, 0, okay. Let's check it out. Oh, sorry. 0, 0, it will maintain a 0 until this pawn. What happened? This H, you can see at the line of this is at the same line as the trigger pawn, right? At this pawn, at S, you consider S is equal to 1. Before the trigger pawn is a 1. What about this line? C also on the same line, right? You consider C is equal to 0. That's it. Nothing more than that. Very simple, right? On this line is before the changes. This is a time. This is a trigger pawn before. S consider it as a 1. C consider it as a 0. That is it. What about this? This is also the same line, right? For S, you consider it as a 0. But for C, you consider it as a 1. Like that only. Now, we talk a little bit on this setup time. What does it mean, setup time? Okay, setup time is the minimum time required to set up the synchronous control input before the active clock transition. Okay, this is a clock, right? This is a trigger pawn, right? We are talking about the input, in this case S and C, right? The time it need to set up before the clock transition. This is what it means. Before the clock transition, okay, it takes some time for the S to be a 1. For example, this guy, okay, the trigger pawn is here. Okay, it takes some time for the S to be a 0. This guy also takes some time for C to maintain a 1, and so on. So setup time is the definition of the minimum time required to set up the synchronized control input. This is S and C is called synchronized control input before the clock transitions, right? Before the clock transition. Hold time, okay, hold time is different. Hold time is, okay, look at the timing again here. Hold time is the time required to hold the synchronized control input after the active clock transition. You check it out. Here, 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 here is the after the clock transition. Okay, that is the time it need, okay, to hold the synchronous control input. Okay, so this is after the clock. This is called a hold time. We talk about this in detail in later on. Some of the topic we'll talk about it in later. A lot of calculation involved in this topic. Yep. So you can read a bit on this. The setup time and the hold time is very important. Okay, if you fail to comply to those requirements, so your flip flop may not be function as what is supposed to expect, right? This one I want you to have a look at that. You study it yourself. This one is not it's not difficult. Just cut the long story short. Okay, you got a clock signal right here. clock signal you feed into here. This is the output through an inverter, right? Cut the long story short, okay? You got a signal here. After the inverter, okay, the output of this inverter, it takes some time from point A to point B, right? Okay, this is what we are talking. You see the clock output here, the output of the inverter is not straight away. Okay, this is a clock signal. It was a 1, not straight away becomes 0. It take a while. After that, take a bit of delay, then becomes 0. You see that? So the clock here, okay, the clock here, okay. So you can see the clock, the output here. So you check it out. Output is depends on this. This is output. This is output. The C clock start. So it depends on the clock CLK bar and not CLK, right? You check it out. Initially is 0. Okay. When it comes to this point, 1 and a 1, right? It's a 1 and so on. You self-study on this topic. Okay, have a look at that. Got problem we discussed in class. Same again. This one you have a look at that. Yep. This one also. You have a look at that yourself. And this one as well. Okay, the internal circuitry. But I'm telling you, exam we won't ask you on those internal circuitry of the 8 trigger things. We won't ask you this. We ask you the application, not to analyze the internal circuitry. Okay, this one also, right? The clock. Okay, cut the long story short. The clock must be very narrow when we turn to 0. Okay, that means this is a clock signal. H detector. This will make the clock more narrow. Okay, clock must be very narrow. It has to return to 0 before the output toggle to the new value. Otherwise, you have problem. All right. You have a look at it yourself. Okay, JK flip flop is a good friend. Is a good friend. Is ours. Okay, JK flip flop is very important topic, right? Important device. Oh, you can see a triangle. This is a pulse trigger. 0 0 output no change. 1 and 0 output change to 1. 0 to 1 output change to 0. When they have a 1 and a 1, 1 and 1 here, the output will be toggle. That means 0 will change to 1, 1 will change to 0. Alright. This same thing happen again, but this is the clock is a negative trigger. The output is also follow the JK condition. We check it out. We do this one, a quick one. Let me show you. This is a clock, right? Positive trigger. You do all this positive trigger. Okay, you identify those first. At this point, okay, what happened? J 0, K 1. What happened? Right? It will be 0, right? Maintain a 0. Okay, maintain a 0 until next trigger point. At this point, what happened? J 1, K 1. That means the output will toggle. That means now from 0 will change to 1. It will maintain a 1 until the next trigger point here. J is 0, K is 0. That means same as before, right? Nothing happened, right? So you maintain a 1 until the next trigger point. Here, what happened? J 1, K 0. So it's a 1, right? So it continue to be a 1. At this point, trigger point, J 1, K 1, what happened? It toggle. Now from 1 change to a 0. You maintain a 0 until at this trigger point, what happened? J 1, K 1, it toggle from 0 change to a 1. Very straightforward, right? Look at the next one. Okay, how do we see this? I want you to see this. Now it's negative trigger, right? Negative trigger, negative, 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 negative. Initially, my Q is equal to 1. At this point, at J 1, K 1, so it toggle, right? Toggle is from 1 change to 0, right? Maintain a 0 until this point, what happened? This J is equal to 0. What happened to K? K is here 1, right? Before, right? On the same line as before 1. So it's 0 and a 1. So output will be 0, right? At this trigger point, what happened? J 1, K 0. So output will jump to a 1. And maintain a 1 until the next trigger point here. J 1, K 1. So the output will toggle. Change from 1 to 0. It maintain a 0 until at this trigger point. J 1, K 1. So it's toggle, right? So from 0, jump back to a 1. Okay. Well, 10 minutes is up. Okay. I will stop here.